Welcome back. We now know what a model is and how to build one using scikit-learn. But how do we get the best possible performance out of it? That's where today's topic, hyperparameter tuning, comes in. So, what exactly are hyperparameters? They are the external knobs or settings for a machine learning algorithm that we, the developers, have to set less than b greater than before less than b greater than the training process even starts. Crucially, they are not learned from the data itself. The best analogy is an oven. The oven is the algorithm, the food is the data, and the temperature and cooking time that you set are the hyperparameters. It's essential to distinguish between parameters and hyperparameters. Parameters are internal to the model and are learned directly from the data during the fit process. The weights in a linear regression are a perfect example. Hyperparameters, on the other hand, are the settings for the learning process itself, like the value of k in k nearest neighbors, which we have to choose up front. Every model has its own important hyperparameters that we can tune. For k nearest neighbors, the big one is k, the number of neighbors to consider. For a decision tree, a critical hyperparameter is max_depth, which controls how deep the tree is allowed to grow to prevent overfitting. And for a random forest, a key setting is an estimators, the number of trees to build in the forest. So how do we find the best values for these settings? We don't just guess. The two most common automated methods are grid search and random search. Grid search is exhaustive. It tries every single possible combination of the values you provide. Random search is often more efficient. It just tries a fixed number of random combinations. Both are designed to find the settings that produce the best performing model. And this is where our validation set becomes critical. We must use the validation set to evaluate the performance of each hyperparameter combination. We never use the test set for tuning. Using the test set would mean our final performance score is no longer unbiased, because we've already used it to make decisions about our model. The test set is for the final grade only. And now you're ready to optimize. Hyperparameter tuning is the process that separates a good baseline model from a highly accurate, production-ready one. It's a key skill for any serious practitioner. We've covered a huge amount of ground in this playlist. In our final lesson, we'll put all these pieces together and walk through your very first machine learning project from start to finish.